You buy a brand new blind, follow the instructions, and go to sleep expecting pitch blackness. But then morning arrives, and you wake up staring at a glowing ring of light outlining your window frame. It is a common frustration. The immediate reaction is to assume the product is defective, or that the marketing itself is intentionally misleading. This frustration stems from window blind myth number 1, the belief that purchasing a blackout blind results in a pitch black room by default. In the window treatment industry, blackout is an adjective describing the opacity of the fabric itself. It is not a guarantee of the final installation's performance. If you isolate that piece of material, it works perfectly. It acts as a solid wall, physically stopping 100% of the light that makes direct contact with it. The failure happens when we treat a material property as a final mechanical solution. Even the most opaque fabric requires a specific installation strategy to function as intended. To see why light still gets in, we must look past the center of the fabric and focus entirely on the physical edges of the window frame. This top-down schematic of a roller blind bracket reveals the core engineering challenge. Manufacturers must leave this empty space on the sides so the fabric can unroll smoothly without scraping the wall or jamming the mechanism. Because those gaps are open, incoming sunlight behaves like a fluid. It strikes the glass and the windowsill, deflects off those surfaces, and pushes through that mechanical clearance gap into your room. The severity of that leak changes throughout the day. When the sun hits the window at an oblique angle, a much higher volume of light manages to slip sideways past the gap compared to direct head-on light. The mechanical design required to make the blind physically operable is inherently at odds with the goal of keeping the room dark. Overcoming this mechanical conflict requires a strategic choice in how the blind is mounted, either tucked inside the window recess or positioned outside of it. This blueprint shows an inside recess mount. Here, the physical confines of the window frame force the entire mechanism to sit flush within the cavity. Because the fabric must be narrower than the hardware to roll freely, this setup leaves a continuous path for light around all 4 edges. That path is what creates the glowing halo effect. The alternative is an outside recess mount. You position the hardware above the window and extend the fabric significantly wider than the actual cavity. This shift relies on overlap, the specific amount of extra fabric extending past the left, right, and bottom edges of the window opening. Calculating ample overlap establishes a physical barrier that light cannot bounce around. As light attempts to escape the cavity, it hits those wide borders and stops cold, neutralizing the edge bleed before it enters the room. Mastering this installation geometry is the only way to override the blind's mechanical limitations and effectively kill the halo. Moving from theory to practice means returning to the ultimate goal, a night of sleep undisturbed by the sun. Achieving total darkness requires a carefully engineered physical environment that accounts for every potential point of entry. Selecting a high-quality blackout fabric is merely the first requirement in building that environment. To achieve professional results, you must begin with exact measurements of the window frame's true dimensions. You then apply those measurements to an outside mount, explicitly calculating the overlap needed to cover the perimeter edge gaps. Failing to control any one of these variables will allow light to bypass the blind, rendering the material's light-blocking properties useless. While a blackout blind alone does not ensure a dark room, combining opaque fabric with precise installation geometry creates a system capable of total, uncompromising darkness.